بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الديناميكا. الدرس اسمه الشغل المبذول بواسطة قوى متغيرة. طبعا احنا عارفين إن الشغل ده درس مهم جدا جدا، محتاج قوة ومسافة. أي جسم بيحتاج ننقله من مكان إلى مكان فبيحتاج فورس اللي هي القوة، والمسافة اللي هي الأس. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in dynamic. Its title, the work done by variable motion. Dear student, the work done by variable force. Look at, dear student, the opposite figure represent the work done by variable force parallel the direction. We have two axes. The first axis represent S, the second is orthogonal or perpendicular, represent force. Dear student, the curve of motion is magnitude of F to move the body from S to A, from S equals A to S equals B. Body moves from A to B. S equals A, S equals B. The curve represent the motion F and S from A to B. Dear student, the work done by the variable force represent by integration from A to B F ds respect to ds. This rule very important. If you want to find the work of variable force, we find integration from interval A to B of F, the force ds. The integration from A to B F ds represent area of the shaded part A1. Remark. Dear student, in the opposite figure, we note that if a part of the shaded area drawn x-axis and the other part blue x-axis, we have two parts, A1, A2. A1 represent the shaded region above x-axis, A2 shaded region below the x-axis. Dear student, we can find the work done of the force by using W equals integration from A to B F ds. By using area, we find area of A1, subtract area A2. Then we note that the work done of the force from A to B represent area of the shaded region A1 minus area of the shaded region A2. The second figure, dear student, if the force F is constant, what you mean constant? Represent straight line parallel S axis. We have two axes. The horizontal represent S, distance or displacement, and F is vertical, represent the force. If the force is a constant, what you mean constant, dear student? Excellent student. F is constant, is meaning straight line parallel x-axis or horizontal axis. Then the work done from A to B is integration from A to B F ds equal what? Equals F multiply integration from A to B ds. Why? Because F is constant. Equals F multiply bracket contains B minus A. Equals also area of the shaded rectangle area of rectangle, you know that length times width. Dear student, unless the direction of the force is parallel to the direction of the motion. Look at the opposite figure. We find the component of the force in the direction of the displacement equal F cosine theta, or equals Fs. Fs represent F cosine theta, component of the force in direction of displacement F cosine theta, or represented by Fs. Then the graphical relation between S and Fs in the opposite figure, then work done equals integration from A to B Fs ds. Remember, Fs is component equal F cosine theta. Dear student, now we are translate to first example. The first example, if we have a body moves in a straight line under the action of parallel force to straight line F equals 2s plus 1, where s is distance between the body and the constant point O on the straight line. Find the work done by this force from s equals 3 meter to s equals 5 meter. Remember, dear student, we have body has force. The force is variable with s. The required is work done by the force from s equals 3 meter to s equals 5 meter. Solution. Dear student, the work done W from s equals 3 meter to s equals 5 meter equals what? X student. W equals integration from A to B F ds by using integration from 3 to 5. A equals 3, B equals 5. We find integration of 2s plus 1 respect to ds. What is the integration of 2s? X student, s squared. Why? Because 2s, its integration 2s squared or 2s power 2 over 2. Integration of the constant one is s. After that, what is the interval? 3 to 5. We substitution about s equal 5. After that, substitution s equal 3. Then find subtraction equal 30 minus 12. Answer equals 18 joule. Then the work done of the force equals 18 joule. Remember, joule is unit of the work. We have joule and urge. Joule equal 10 power 7 urge. But in this example, the work equal 18 joule. Another example. Dear student, this example is very important. We have a body moves in straight line under the action of parallel force to this straight line. Its magnitude F equals 3s squared plus 2s plus c, where s is the distance between the body and the constant point O on the straight line. If the work done by this force to move the body from the point O to the point at which s equals 2 equals 22 work units. What is the required? Then find the needed work to move the body from s equals 2 to s equal 6. Solution. Dear student, the work done W1 from 0 to s equals 2 equals integration from 0 to 2, 3s squared plus 2s plus c ds. Dear student, we have force. F equals 3s squared plus 2s plus c, the required work done from 0 to s equals 2. The fourth variable in s, we find integration from 0 to 2. What is the integration of 3s squared? X and student, s power 3. What is the integration of 2s? X and student, s power 2. What is the integration of c? cs. After that, the integration s power 3 plus s power 2 plus cs from 0 to 2 equals the work done equals 22. Then by substitution about s equals 2 and about s equals 0, then 22 equals 8 plus 4 plus 2s, 2c, then c equals 5. After that, the needed work from s equals 2 to s equals 6. We find integration from 2 to 6. 3s power 2 plus 2s plus c ds. After that, by using integration and expressed by the work, then the work done is 216 plus 36 plus 30 minus 22 equals 260 work unit. Another example. Dear student, look at the opposite figure illustrates the action of variable force. Look at the opposite figure represent two axes. The horizontal axis represents the distance s. The vertical axis represents the force F. Look at from the origin point 0, s, when s equals 0, F equals 0. When s equals 2, F equals 6. When s equals 6, then the force equals also 6. When s equals 8, the force equals 0. When s equals 10, the force equals negative 6. When s equals 12, then the force is equals 0. The opposite figure illustrates the action of variable force F measured in Newton of a body moves displacement of magnitude S measured in meter. Find the work done by this force when body moves, number 1, from S equals 0 to S equals 8. Remember, dear student, look at the opposite figure above S axis from S equals 0 to S equals 8 represent X student, trapezium. What is the trapezium? This figure above S axis represent area of a trapezium. What you mean area of trapezium? Have sum of two bases times height, or base 1 plus base 2 over 2 times height. Look at, dear student, from S equals 0 to S equals 8, and from S equals 8 to S equals 12. From S equals 8 to S equals 12 represent, yes, area of what? Area of triangle. Area of triangle have base times height, but area of trapezium equal base 1 plus base 2 over 2 times height. After that, how to find the work done from S equals 0 to S equals 12, from S equals 5 to S equals 10. Look at the solution, dear student. Look at W1 from S equals 0 to S equals 8. We find integration from 0 to 8 f ds. What is the integration from 0 to 8 f ds? Represent area of isosceles trapezium. No isosceles trapezium. This also trapezium ABCO or OABC trapezium represent integration from 0 to 8 f ds. Area of a trapezium or trapezoid OABC equals what? Half bracket contains 8 plus 4 times 6. What is the 8? The base 1. What is the 4? The base 2. What is the 6? Is height. Area of a trapezium have sum of two bases times height equal 36 joule. Then the work done of the force from S equal 0 to S equal 8 represent area of a trapezium OABC equals what? 36 joule. Then what is the work done from 8 to 12? Look at, dear student, from S equal 8 to S equal 12, we find work done, integration from 8 to 12 f ds equals what? X and student, area of triangle. What is a triangle? CDE. Then area equals half times 4 times 6 equals negative 12 joule under S axis. Then work done from S equals 0 to S equals 12 equals integration from 0 to 12 f ds. What is the integration from 0? Equal the area of trapezium OABC plus area of CDE. Then area equals 36 minus 12 equals 24 joule. Dear student, look at from S equals 5 to S equals 10. Look at from S equals 5 to S equals 10. Integration from F to 10 f ds. Look at the shaded or green shaded region from F to 8, then from 8 to 10. From S equal 5 to S equals 8 is called area of trapezium. Area of trapezium base 1 equals 1, 2, 3, 4 from 5 to 8. Base 2 equals 1 from 5 to 6. What is the height? Equals 6. Then area of, yes, excellent student, trapezium, its bases 4 and 1, its height equal 6. Area of triangle CDK equal half base times height, half 2 times what? Times 6. Then find the required region. Dear student, we use area of trapezium B X Y C minus area of CDK. Then area equal half times 1 plus 3 inside bracket times 6 minus half times 2 times 6, area equal 6 joule. Then the required work equal 6 joule. Dear student, now we are translate to kinetic energy. Kinetic energy is very important lesson. Definition. The kinetic energy of particle denoted by capital T is defined as product of half of mass of particle times square of the magnitude of the velocity. Then T equals half mv square. Dear student, we have mass, its symbol m, v, its symbol represents the velocity, kinetic energy represented by capital T equals half multiply mass times square of the velocity. Dear student, m, note that m is mass of particle, v vector is magnitude of the velocity, v. From this definition, we note the following. Number one, v magnitude equals absolute norm vector v velocity. V or magnitude of the velocity equals norm of the vector v. V square, magnitude of v square equals norm or square norm of vector v equals v dot v. Kinetic energy of particle is scalar quantity, not negative, must be positive or equal 0. Then T or kinetic energy must be more than or equal 0. Equal 0 when the velocity vector vanishes. When v equals 0, then kinetic energy equals 0. Dear student, kinetic energy may be equal 0 or more than 0 or positive. Why? Because v not equal negative. Then kinetic energy more than or equal 0. When T equals 0 or kinetic energy equals 0, then the velocity vector equals 0 vector, or v magnitude of the velocity equals 0, or v is vanishes. The particle which moves with uniform velocity, its kinetic energy is constant. Remember, dear student, the particle which moves with uniform velocity. What you mean of uniform velocity? Equal distance in equal time. Then its kinetic energy must be constant. While if the velocity is variable, then kinetic energy is also variable, and it will be the kinetic energy at certain instant, or equals half m times square of the magnitude of the velocity at this time or at this instant. Then, dear student, kinetic energy equals constant when the body moves in uniform velocity, but kinetic energy is certain when the velocity is variable, as kinetic energy in this case equals half m or half times mass times square of magnitude of the velocity at this time or at this instant. Proving that the measure unit of kinetic energy is the same unit of measure of the work. Dear student, this proving is very important. How to prove measure unit of kinetic energy is the same unit of measure of the work. Since kinetic energy equal half mv square. Then the unit of measure of kinetic energy equals what? Measure unit of the mass times square of measured unit of the velocity. What is the measured unit of the mass, dear student? Excellent student. The measure of kinetic energy equal measure unit of the work. Dear student, by ends of the lesson, we know that kinetic energy is equals half mv square. M is mass, v is velocity, and we know that unit of kinetic energy is the same unit of the work. Dear student, I'm very happy to spend such time with you